Hey there, folks. It's May. We're down to our last two assignments in computer science principles. And of course, some of you will be um, working on your AP create task and explore task. I'll be posting more information on completing those shortly. So this week's lesson is 3.2.1, which is titled Inferential Statistics. I know a lot of your juniors next year will probably be taking AP Statistics with Mr. Barrett or Miss Edwards or whoever's teaching that next year. And a lot of what you're going to be learning next year comes or is related to um, this section right here. So, in inferential statistics, mathematicians create models to describe some real thing. When they create this model, it's an example of an abstraction. We've talked about abstractions quite a bit this year, and if you're doing the AP create task, you definitely need to be talking in depth about your abstraction. So statistics, they use abstractions as well because the idea of an abstraction is that it manages the complexity of information. So for us in computer science, when we're managing complexity, that means we're making a list or a procedure or function to take some of the detail out of this part of code. When we make a model in statistics, it's an abstraction because we're just modeling one aspect of some idea and trying to take out some of the finer details and really just focusing on one thing. So, there is a big Replit project here that comes with this lesson, and there are a lot of files in it. And when there are a lot of files, that means you have to import them and then run the main method in each one of those. So this lesson starts off talking about comparing two categorical variables, which in this case, the categories are what grade are you and do you text or not. So this is kind of an older example back when texting wasn't quite as frequent as it is with all the apps and whatnot nowadays. But what they're trying to do is they're making a model to determine whether statistically juniors text more than seniors or vice versa. And when you make a model like this is a Monte Carlo model, which they explain what that means somewhere in here. Where is that? I have to search for it. There it is. So they're using random numbers, and that's called a Monte Carlo simulation. The model assumes that sophomores and juniors are both 72% likely to text. The simulation often generates data in which a much higher or much lower percentage of 72 students um, use texting because the numbers generated are random. It doesn't always pop out exactly 72%. It can go much higher or lower. So a recent event that this is very related to, and the current event it's very much related to when we're making models. A lot of people are trying to model how the things are going to shake out with our COVID-19 virus. They're trying to create mathematical models for number of cases, number of deaths, and you've seen, our president updating the numbers on those models quite frequently because a lot of things are uncertain about how this pandemic is going to play out. You might have heard people talking about getting the R value below 1. That R value is related to um, how many people are getting infected by each person that already is infected. So, of course, we want to get that R value below 1 to make our numbers go down instead of up. But another related recent event was our 2016 election because Hillary Clinton was expected to win, and a lot of models showed her having about a 70% chance or maybe an 80% chance of winning. And so most people coming into election night were like, well, okay, she's got it in the bag. Well, obviously, Hillary Clinton's going to be our next president. And it obviously did not turn out that way because Donald Trump had a 20 to 30% chance of winning. And that's not nothing. Um, just because you have a 30% chance of winning, it doesn't mean that you're not going to win. It means you're going to win 30% of the time. And I think a lot of people misunderstand those kind of statistics. Just because Hillary's percent was more than 50 doesn't mean that she's definitely going to win. So these models are trying to predict things and model situations, but um, the very nature of statistics and inferential statistics is things are still uncertain. We're just trying to find what the most likely situation is. Um, so this part number 4 here, you'll definitely be talking about next year in statistics if you're taking that, or if you're taking it this year, you probably talked about it quite a bit, which is the confidence interval and a p-value. The p-value is a measurement of um, how likely it is that a difference occurred in our statistics based on randomness. So we're trying to get this p-value, this measurement below 0.05. That's the accepted measurement by statisticians, because we want to say there's a very, very low chance that these two statistics were different just based on random chance. So with this sophomores and juniors one, you could run this simulation a whole bunch of times and you're pretty unlikely to get a p-value below 0.05 because the differences that show up are just random differences. It doesn't really mean that sophomores text less than juniors or vice versa. It says that you'd have to run it about 20 times before you're likely to get a p-value below 0.05. But that for statistics, that's what we want to get. If we're trying to say that these two things are related, sophomores definitely text more than juniors, then we want to get a p-value of less than 0.05, so that difference isn't just random chance. As we get down through the lesson here, the next simulation that we're running is heights of 14-year-old and 17-year-old females. So again, what we're trying to do here is see if these two things are definitely different on average or only different by random chance. So you can see two um, results of running this simulation. In one of them, the p-value is 0.07. So you can see that the average heights are different, but not different enough that they're for sure that it's not just random. But then the next time they ran it, um, it turned out that the heights were significantly different. And you can see that the p-value there is 0.03, which is less than 0.05. So when we ran it this time, we might be more likely to say, yeah, 17-year-old females are definitely taller than 14-year-old females on average. And then those random numbers in those models are based off of defining an average height and then a standard deviation, which I'm not going to really get into too much here. This isn't a statistics class. It's more about understanding how we use models and then creating those models in Python. So in your assignment, you're going to be running these simulations, answering some questions about them. As you get down here below, you're going to be running this one, which creates a bunch of graphs, trying to see if any number of variables are related to each other, like height versus weight, gender versus height, that kind of stuff. And then next week, we will be doing some web scraping. So I'm skipping over the middle part here, which is the Weather Underground stuff here, and it mentions web scraping. That's going to be our assignment next week, which is taking data from the internet um, and using it however we want to answer a question, a statistical question of some kind. So that's it. Go check out the assignment. It's just going to be running the code a little bit and answering some questions about it.